Hi, my name is Helena Panchenko, and I am here to show you homework 2, problem number 8. So this exercise gives us a standing wave that is oscillating at a given frequency. We are asked to explain how the antinodes of the wave will change when we double our original frequency. So I redrew the given wave because I think it is important for us first to distinguish the nodes from the antinodes. So the nodes are the point at on the wave that don't move, and they're spaced half a wavelength apart. So they occur at these points right here. The antinodes occur halfway between the nodes and are the point at which the particles in a given medium will oscillate to their maximum displacement. So these points right here are our antinodes. In our original wave, there are 4 antinodes. So let's begin to approach this problem by considering our favorite equation, distance equals rate times time. So our distance here is the wavelength. Our rate is the speed at which the wave is traveling. Our t, or our time, is the period, which, if we can recall, the period is equal to 1 over the frequency. So we can rewrite it in terms that we like, and let's do some algebra to balance out the equation into a more feasible form. And we are left with this equation that describes the relationship between the wavelength and the frequency to produce the speed of the wave. So now we're going to look at what happens to this equation when we double our original frequency. So the speed of the wave is going to maintain and keep constant. So with our new frequency equaling to 2 times the original frequency, we will get an equation that looks like this. So now I'm not really sure how to explain this because usually I just kind of know this by algebra, but we kind of have to balance these 2 equations. See, if we double our frequency here but want to maintain the same speed that we started with, we have to cancel out the doubling of the frequency. And we can do that by cutting the wavelength in half. So this equation is all balanced, and this will produce a very different looking wave. So now we have our new wave with a doubled original frequency and half of the original wavelength. We can now count how many antinodes there are, and those again are they occur halfway between the nodes, and there are 8 of them. In this new standing wave, the wave speed is held constant, and therefore, when the frequency is doubled, the wavelength is halved, producing 8 antinodes rather than the 4 original antinodes.